In this episode, you'll learn the exact maintenance shortcut that brought down a plane in under a minute, and why the shortcut wasn't one mechanic's mistake, it was an entire industry's blind spot. 1979. A plane takes off, climbs to about 300 feet, and then just stops flying. Investigators found the cause wasn't some random malfunction. It was a maintenance shortcut approved to save time that quietly removed a safety redundancy nobody thought to double check. 273 people died in under a minute. Scheduled departure out of Chicago, a route flown constantly on a widely used wide-body aircraft. Nothing about the day stood out. Experienced crew, clear weather, solid safety record on this aircraft type. Takeoff roll, normal. Liftoff, normal. Then, at a height where recovery from almost any survivable failure should still have been possible, something went catastrophically wrong. As the plane climbed, its left engine mounted under the wing on a structural pylon separated completely. Not just lost power, broke away, fell to the ground. Here's what made it so severe. As the engine tore free, it damaged systems running through that section of the wing, including the hydraulics controlling the leading edge slats. Panels that extend to help generate lift at low speed, exactly what you need right after takeoff. The left wing's slats retracted, the right wing stayed extended. Mismatched lift on two wings at low speed right after takeoff. The plane rolled left, banked into a position that killed even more lift, and the crew, who'd also lost several of their warning systems in the same failure, couldn't recover in time. Engine separation to crash, well under a minute. The engine didn't fail on its own. It separated because of cracking in the pylon connecting it to the wing. That cracking traced back to a maintenance decision made months earlier, one that had nothing to do with this specific plane and everything to do with an industry-wide shortcut. The manufacturer's official procedure removed the engine and the pylon in two separate steps. Several airlines had switched to an unofficial method, pulling the engine and pylon off together using a forklift. Faster. Fewer labor hours. Here's the problem, and it's easier to picture than it sounds. Bend a paperclip back and forth a few times, nothing visibly changes. Keep bending it, and eventually it snaps, at a point that was quietly weakening the whole time, with zero visible warning. Pulling the engine and pylon off as one heavy combined unit put stress on the mount in a way the original design never accounted for, because it was never supposed to be handled that way. If the supporting equipment wasn't positioned with near-perfect precision, the pylon could crack slightly, invisibly. This exact aircraft had gone through that combined removal about a month before the crash. A small crack likely started then, and kept growing with every flight after until it finally gave out on this takeoff. This is the part that turned a single tragedy into an industry-wide reckoning. This shortcut wasn't one mechanic's bad call. It had spread across multiple airlines flying this aircraft, adopted independently because it saved time and hadn't caused an obvious problem until it did. Because the change happened at the maintenance level, not through the aircraft's original certification process, there was no clear channel to flag the risk. Nobody ran the numbers on what combined removal actually did to the structure, because nobody using the shortcut had reason to think it needed testing. Regulators grounded the entire aircraft type for over a month, inspected the fleet, and banned the combined removal procedure outright. But the bigger, lasting change was structural. Airlines now have to prove that any deviation from a manufacturer's exact procedure has been formally reviewed. This aircraft kept flying for decades afterward with a strong safety record. That's actually the real lesson here. The plane's design wasn't the failure. A shortcut nobody reviewed was. If you've ever caught yourself taking a faster shortcut at work that skipped a step someone designed for a reason, comment it below. I bet this hits closer to home than you'd think. A shortcut. Approved because it looked equivalent on paper and nobody sent it back through the math. Remember that pattern. It's going to show up again and again. If stories like this, where the failure is really a communication gap, not a single villain or your thing, please subscribe. Like this video if the paperclip analogy landed for you, and tell me in the comments, bridge collapse or engine failure, which one got you more?